Diameter of a circular disc is measured as 7.0 plus minus 0.1 millimeters. So we represent diameter D is equivalent to 7.0 plus minus 0.1 millimeters, where the uncertainty of the diameter is said to be 0.1 millimeters. Now, all uncertainties must be in one significant figure. So the question is asking what is the area of the disk and the absolute uncertainty in the area. So we want to know what is A as well as delta A. So we know from the formula for area of a circle is going to be A equals to pi r squared, where the relationship between diameter and the radius r will be equivalent to d over 2 squared. So this would be your formula for the area. So we can actually expand this to become pi over 4 multiplied by d squared. So here we can just substitute the value of d given as 7.0 squared. Here you'll get roughly around, if you plug in your calculator, pi over 4 multiplied by 49. So you get 38.48. 38.48 millimeters squared. So this would be your area, given the new formula that we use right now, which is expressing the area in terms of the diameter instead of the radius. Now, to calculate the uncertainty of the area, delta A, so we look at this formula. So we notice that this is d squared. So in order to get the absolute uncertainty of A, what you need to do is delta A over A, which is using the fractional representation of our uncertainty value, would be delta D over D, because this is squared, so we just multiply by 2. So the absolute uncertainty of the area A will be equivalent to 2 delta D over D multiplied by the area, where the value of area we already calculated as 38.48. So substitute the values. Delta D is equivalent to 0.1, D is 7 multiplied by A, which is 38.48. So here, roughly you'll get your answer. Plug into your calculator. 1.0994. So what value or what significance do we use in order to represent our delta A? It must always be in one significant figure. So when you round off this 1.0994 into one significant figure, so you just get 1. So this is in one significant figures. So combining between this value of delta A and your A, so overall, so you get your answer A is will be equivalent to 38, because you just want to round it off to the nearest decimal place here, which is only one significant figure, plus 1 millimeter squared. So that's why the answer is B. So just notice that for this, what you need to do is, for any uncertainty, it must always be in one significant figures. And then your measurement data A must follow the number of decimal place that is contained inside your rounded off to one significant figure uncertainty value. So in this case, there is no significant figure. There's only one whole number, 1. So your value would be equivalent to 38, which is no decimal place, and so on.